may not seem like much, but there are many forces that work here, like everything else here and on this arrow. For example, this arrow has at least 4 forces that are acting on it. You have thrust, lift, friction, and gravity. Thrust would be the force on the arrow when it is released on the bow. Friction is the opposite of thrust and will slow down the arrow until it comes to a stop or hits something else. Lift and gravity are also opposites. Gravity allows the arrow to stay on Earth just like it allows us to stay standing on the ground with our own 2 feet. Lift is what keeps us upright and what keeps this arrow in the air as well. Besides that, there is another force. It is called inertia. The law says that if an object is in motion, it stays in motion. If an object is at rest, it stays at rest, unless it is hit by an unbalanced force. Here, the arrow is at rest before it is released. When it is released, it flies and hits the target and is stopped by the friction. There's also a second law known as force equals mass times acceleration, and it explains how the acceleration of an object depends on the mass of the object and amount of force that is on it. So if you know any of the 2 out of 3 components in the equation, you will be able to find the third one. Let's say you knew that the force of the arrow was 20 newtons, and the acceleration of the arrow is 10 meters per second. You would be able to find the mass of the arrow using the information by plugging it into the equation F equals ma. After that, it's just math. Divide 10 on both sides and you will find the mass of the arrow. It's not just the mass you can find though. You can find either the force or acceleration if you know any of the 2 variables in the equation. There is also Newton's third law. For every action, there is an equal and opposite reaction. So here, the arrow hits the target, and according to Newton's third law, the opposite reaction will be the target hitting the arrow. These are also known as force pairs. There is also something called net force, which is the combination of forces acting upon an object, which to us would mean the push or pull on an object. Here, I'm pushing the bow. So let's say that is about 10 newtons of force, but I'm pulling the bow as well in the opposite direction. So let's say that is 10 newtons of force in the opposite direction. That would make the net force 0 newtons since it is stable. Another way to think of it is positive 10 plus negative 10. But let's say it was 10 newtons left and 12 newtons right. You would then have to subtract the 10 from the 12. You would end up with 2 newtons, and since the larger number is on the right, the net force would be 2 newtons left. Now, if the 2 forces happen to be in the same direction, you would just have to add them up to get the net force.